Hello everyone, in today's video we will be discussing the fundamental concepts of Docker. In this video we are going to talk about Dockerfile, Docker image and container. Understanding these concepts is crucial for anyone getting started with Docker. So let's dive right in. Before we start with Dockerfile, Docker image and container, let's clarify what Docker is. Docker is a technology that allows you to package and run software application in a consistent and isolated environment. It's like a container for your application. Imagine you have a special box called Docker container. Inside this container, you can put all the necessary things your application needs to run, such as your code, libraries, and dependencies. It's like a self-contained package. Docker helps you keep everything organized and ensures that your application runs the same way on any other computer or server that has Docker installed. It eliminates the problem of "it works on my machine" because it provides a consistent environment for your application to run. With Docker, you can easily share your application with others, knowing that they will have the same environment to run it. It also makes it simple to deploy your application to different servers or cloud platforms because the container can be easily moved around. Now, to understand how Docker works, there are three things you should know: Dockerfile, Docker image, and container. Dockerfile, you use a special file called a Dockerfile to create these containers. A Dockerfile is essentially a recipe or a blueprint for building a Docker image. It contains a set of instructions that specify the base image, adds file and dependency, configures settings, and define the commands to be executed within the container. Now let's talk about Docker image. And Docker image is a lightweight, standalone, and executable package that is created from a Docker file. It's like a snapshot of a specific application or service, along with its environment. This image includes all the necessary components such as code, runtime environment, libraries, dependencies, and configuration files. Think of it as a template or a blueprint for creating Docker container. Finally, we have container. A container is an instance of Docker image. It's like a running isolated environment that encapsulates the application and its dependencies. Containers provide a lightweight and consistent runtime environment, ensuring that the application runs the same way across different systems. Containers can be started, stopped, moved, and even deleted, allowing for easy management and deployment of your application. So, let's summarize the difference between a Dockerfile, Docker image, and container. A Dockerfile is a set of instructions used to build a Docker image. A Docker image is a packaged software that includes everything needed to run an application. A Docker container is a running instance of Docker image, providing an isolated and lightweight runtime environment. I hope this cleared what is Dockerfile, image, and container. Now we are going to learn how to containerize a Node.js application using Docker. The first thing you need to do is install Docker on your computer. Docker provides versions for Windows, Mac OS, Linux, so choose the one that matches your operating system. Head over to the Docker website, download the installer, and follow the installation instruction. Don't worry, it's a straightforward process. Now let's open our VS Code and create a file called app.js. In this file, let's console log hello Docker, and let's save this file now. Next, we will create a Docker file, which is like a recipe, and tell Docker how to build your container. Create a new file in your Node.js application root directory and name it Dockerfile with D capitalized and remaining letters lowercase. Open this file and let's start adding some instructions. In the Docker file, the first line typically specifies the base image to use. You can think of the base image as the starting point for your container. For a Node.js application, a good base image is node:\latest because it includes Node.js pre-installed. To keep things organized, let's set the working directory inside the container. This is the directory where your application code will be copied. Add the following line of code to your Dockerfile. Now let's copy your Node.js application files into the container. We are going to copy all the files in the current directory into the app directory into that image. Finally, we need to specify the command that Docker should run when the container starts. Add the following line to your Dockerfile. With the Dockerfile ready, it's time to build your Docker image. Open your terminal or command prompt, navigate to your application root directory and run the following command: docker build-t hello docker and then puree. Docker will read the Docker file, pull the necessary dependencies and build the image for you. This might take a few moments. Now, as this is done, let's run the command docker image ls. This command lists all the Docker image stored on your local machine. It provides valuable information such as image ID, repository name, tag, and size. The output will give you a clear overview of the Docker image you have available. The image ID uniquely identifies each image. The repository name denotes the name of the images, often in the format of repository tag, where the tag represents a specific version or a label for that image. The size column shows the disk space occupied by each image. Now that you have built this image can run on any computer that has running Docker. So on this machine, which is my development machine, I can say docker run and then type the image name hello docker. Now look, we see the message hello docker on the terminal. And now when you open your Docker desktop application, you will see the name of the container, and when you click on it, it will show you the message that is hello docker. That's it. You have successfully containerized your Node.js application using Docker. This is all for this video, and I'll see you in the next. Till then, bye bye and happy coding in containers.